How is everyone today? All right. So I've gotten a lot of your test corrections, so I don't have to kill you, which is great. All right, give me a second. Oh, more of you. Okay. I think today warrants a brand new marker. You have no idea how many markers I own right now. It's ridiculous. I think I'm close to 100, but I go through them. Okay. So today we're actually going to learn something new, boys and girls. Yay! Okay, yeah, right. Yeah, shut up, Bronco, and just teach. Okay, so today we're going to cover homogeneous differential equation. No, wait, not homogeneous. We already did that one. Linear. Whoops, sorry, linear. See, it's not a good thing when the first thing that the marker writes is wrong. So this one's gone. New marker. Linear differential equations. Okay. Linear differential equations are of the form y prime plus f of x y equaling g of x. This is an important form because it pops up a heck of a lot. Okay. Now, let me give you an example. Something like that. Now, sometimes it has to be rearranged. Okay. Like we got to do some, a little algebra to play around with it to get it in this form, right? Or, something like tangent of x y prime plus 2y equals 1. Like that would be another example, okay? But you have to get this tangent out of here. So you would divide everybody by tangent, and then it would be in the right form. So you would do y prime plus 2 cotangent of x, y equals cotangent of x. You see what I mean? So like that would require a little algebraic manipulation.
So are these not separable?
No, no. Like for example, that is not going to be separable. You see? I mean, you could move the xy over to the other side, but you're not going to be able to get the y out of that one and not, it just wouldn't separate. And if something is separable, then for all intents and purposes, be my guest, separate it. Separable is easy. But for things that are not separable, sometimes this is the tool to use. So let me give you an example about, and let's just do a simple one, okay? Let's do y prime plus, let's say, x squared y is equal to x. Okay, so to just kind of like toss around what Ridvik was saying, if we tried to separate it, y prime is equal to x minus x squared y. You see, I can't factor out a y to be able to divide it out. You see, so separable doesn't work. So what we do is a very, very interesting little trick. And I don't know who came up with it, but whoever it was pretty slick. We introduce what is called an integrating factor. The integrating factor comes from this. This is why it has to be in this form. Because whatever is inside that red box is gonna be this. Yes, we are putting an integral in an exponent. Okay. Now, let me just go through an example and show you how this one's going to work. Okay. So this becomes e to the x cubed all over 3. Now, the cool part is that I'm going to take this integrating factor and I'm going to multiply it to everyone in the entire equation. So I'm going to have e to the x cubed over 3 y prime plus x squared e to the x cubed all over 3 times y is equal to x e to the x cubed all over 3. And of course, I have to make a problem that's a problem. But watch. Here's how it works. Now, here's the trick. You got to look at this mess really, 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 really carefully. And before I go too deep, I want to remind you of something that we've already seen. Just off to the side, I want to jog your memory. If I have two things, u and v, and I take the derivative of them, that's the product rule. And the product rule says that it is u prime v plus uv prime. Agreed? Now, I have the commutative property of addition. U, keep it the same. U prime v. So I like that form for just right now. So if we look at that, and we look at this very, very, very carefully, notice I have a thing, and I have the derivative of that thing, so u and u prime, a v and a v prime. And what this really is this. Take a second and put your brain around that for a minute. It's easier to imagine going up. If I take the derivative of this thing, it's the product rule. Leave the first one alone, take the derivative of the second. Plus the derivative of the first guy, because remember, that's the chain rule. The derivative of this is itself times the derivative of the stuff inside, which is that. And then you leave the other guy alone. Do you see it?
Who came up with this?
Some freaking genius. I don't know. But then again, there are mathematicians that spend their whole lives on differential equations. It's fun. So now what this really is saying in Leibniz notation is the derivative of e to the x cubed over 3 times y dx is equal to x e cubed all over 3. And then we take this guy over to the other side and integrate.
Wait, so is it on the left side? Is that a what variable
That is the integral of 1 with respect to e to the x cubed over 3 times y. And since this is the thing that I'm integrating with respect of, this just becomes that. And then you're going to integrate this other side, which is a hot mess. And go from there. And I'm not going to waste our time working on that integral. But that's the point. Now, when you're done with this term, my integrating factor, comes on over to the other side. So you get y alone. Just want to make sure everyone puts their brain around that for a second. All right, now, where are we? So let's do some real examples. Now, by the way, that means that we can basically think about this in a nice, happy format. If I have y prime plus f of x, y equaling g of x, okay? Your answer looks like y prime e to the negative integral of f of x dx times the integral of g of x times e to the integral f of x dx dx. Okay, so that's the general form of your answer. Let's do some examples. Let's do something with nothing too bad. Let's do y prime plus 2y equals e to the x. So my integrating factor is e to the integral of 2 dx, which is e to the 2 integral of dx, which is e to the 2x. Now I'm going to actually go through all the steps on this so that you can see it and do it a few times. And then once you've gotten like, you know, fluid with it, you can jump to your answer. Okay. So e to the 2x y prime plus 2e to the 2x y is equal to e to the 2x times e to the x. And this guy boils down to d dx of my integrating factor times y. And this combines to e to the 3x. I bring the dx over and integrate both sides. This guy just becomes itself. And this guy integrates and now I need to get rid of him to get y alone. And I get e to the negative 2x 1 over 3 e to the 3x plus c. Do not forget, people, that this constant is here and you are multiplying. Oh, well, you're dividing, actually. You're dividing this to everyone, which means it's going to be on that guy too. And of course, if you wanted to simplify it, you could. And you would have e to the x all over 3 plus c all over e to the 2x. And that's your honest to God answer.
So, Mr. Ronca,
Speak to me, brother.
when you're integrating with respect to something, is that basically just integrating the derivative of that thing?
Okay, so I don't understand.
Because you said when you integrate d times something, that's integrating with respect.
Well, it's not multiplication, really. It's an operation. So, like, for example, this d operator, it's not multiplying. It's like saying, think about it this way. D of cow over dx. What this is saying is, how does the cow change when x changes? Okay, so it's not really multiplication, and just in the same sense as that's not multiplication either. You see, it's an action, right? And so if I say that d of cow is equal to 1, what this is saying is whenever x changes, cow changes at the same amount because it's 1, right? These two change at the same speed. Okay, this is a ratio, like miles per hour. Like if 1 hour goes by, 1 mile goes by. If 1 mile goes by, 1 hour goes by. Okay, if 10 miles go by, then 10 hours go by. That's why it's 1. So if I take this over to the other side, and integrate, this is saying, how does, in this case, what we're saying is, as cow changes, how does 1 change? Well, 1 changes as much as the cow changes. Okay, so
Okay.
I don't care. I mean, and that's why I used a cow. It doesn't matter what the heck is inside that. Okay, now if you had something like this, if you had a function of cow, if you had then this would be cow cubed plus c. But if you had instead the integral of dog d cow, the problem is that dog doesn't have any relation to cow. There is no cow in that dog. So therefore the dog is a constant. And then you just have a dog cow plus c. Does that helpfully clear it up?
Yeah, I think it does.
Cool.
Thank you.
No problem. My farmhouse calculus. Yay. Okay. Telling you, man. Farmhouse calculus rocks. Worked for old McDonald. All right. So let's do, how about you try, this one's nice. Do this first. Figure out what the integrating factor is. And put the integrating factor in the private chat. I have 4 right answers, 2 wrong answers, and 3 answers that need to be simplified. Make that 4 answers that need to be simplified. What happens to that?
Comes X.
Yeah, e is the base of the natural log. So it's just x. Now I've found my integrating factor. Now I multiply it everywhere. Now, if you look at this one, you can really see that it is the product rule. I hope that that's clear. The derivative of one and the derivative of the other, and the other guys are left alone. So now what I want everyone to tell me is, what am I writing on the left-hand side?
Would it just be X and Y
Well, there's a little more to it.
around
Right, it's in the.
X, Y prime. Like X, Y quantity.
Let's give everyone an opportunity. That's right. I like that one, Andrew. Okay, so most of us are writing it in the form I like. Many people wrote this, and that's not wrong. It's correct, but it's not the most useful form. The most useful form is this form. That's the most useful form. It's the Leibniz notation, because now I can show the dx present, right? In this form, you don't see the dx, right? You don't see it anywhere. But here you do see it. And then it makes sense where it comes from and where it goes. So this is the form I would like. And now I've got dxy equaling x to the negative 2 dx integral. And now I think, well, this left-hand side, I think we all, because we had a conversation about it, this whole left-hand side just boils down to that, and that's all. Well, equal sign, right? That's him. Now I want everyone to do this fellow and solve for y.
Oh, put that in the chat too.
Yeah, would you please? Private chat, so that, yeah. Okay. I am seeing many correct answers, but I'm also seeing people forgetting about the constant of integration. You need to keep track of your constant of integration. So this is a power rule. This is x to the negative 1, and then you multiply it by the reciprocal, which is negative 1, plus our friend, the c. So what we have is something like c minus 1 over x. And now I divide by x to get y alone, and I get c over x minus 1 all over x squared. And you could have written that in many different ways. Okay. You know, I mean, but this is the general idea. You know, some people that had theirs, you know, with the commute of the property of addition. Other people had it where they factored out a x 1 over x, and that's all fine. Okay. But I think we all know if your answer was this or not. Okay. Some more? Yes. Good. Excuse me. How about Okay. Has everyone got it copied? Okay. When you're done, just put your answer in the private chat. Okay, did everyone get there? And if you didn't, figure out what went wrong up to there. Okay, so take a look if you didn't get it or how close you got. Okay. Now, let's do one like this. Why? Where am I? I just lost my spot. I should just teach the whole class like this. Be like, all right, people, what's my integrating factor? Yeah. So this one wasn't so bad, I hope. And here I am kind of jumping to the end by knowing what that form, that generalized form was. And here you can see that if we go back to that generalized form, it was of this shape. This is your integrating factor with a negative out in front. So when that integrating factor comes over to the other side, it's a positive. And I could have brought it over here, but then you see that it's the integrating factor, which was that, times the stuff that was originally in it, integrated, gives me that generalized form again.
Wait, on the left side, when it says your answer should look like, is that supposed to be a y prime?
Be why that's the actual solution. So let's see if we can do this without a lot of pain. Let's do, I thought I already did that one. No, I didn't. Okay. And I want the answer that passes through the point 1, 1. So first figure out what your integrating factor is, and then jump to the answer.
What was the point it passed through again?
1, 1. Give me a second. A lot of right answers, a couple of close answers. Did you see where you might have made a mistake? Ready for one more?
Wait, hold on. I'm a little confused here.
Okay, what can I help you with?
So you, so y prime times quantity x minus, oh no, sorry, from the step below, from y prime, the step below that, how do you get from there to there?
How do I get from there to there?
Oh, no, from that
There to
step
here?
to the, yeah.
From here to there? I divided everyone by this.
Oh,
And this is a straight U sub. And then multiplying that to everybody. So there's a lot of steps in here, right? There's a lot of moving parts. But that's part of the fun, is that it's got so many things going on that it's fun to play with. Yeah, my definition of fun, Mark, not yours. My definition of fun involves high school students in tears. And yes, that was recorded. I'm okay with that. They always say we should tell the truth. All right. So let's see if we can copy those down.
oh, are we ever gonna get those textbooks?
I haven't heard from Hodgson what the deal is with that.
Oh.
Now, I don't know what they're talking about with a minus plus here. Let me look at the answers real fast. Hold on. You want the answers? They're right there. I think it's supposed to be a minus. I don't think it's supposed to be a plus.
It's like blurry. Like it's hard to differentiate. Like all
Oh, cry me a frickin' river. It's blurry. My gosh. Give the man a mountain of silver and he says, why isn't it gold? Jeez. All right. Does everyone have a picture of it?
Could you
What was it?
email a screenshot of it?
Like, can you go back to the homework? We didn't. I
Yeah.
never finished copying down the homework.
Oh my God, slow.
Wait, so what is it a minus plus? What was it?
No, it's supposed to be a minus.
Okay, just a moment.
It's a minus. Okay, I'll give you a screenshot. Oh my gosh. Let me see if I can do a file. And now I'll do another one just for your answers. Separable, integrating factor. Here we go. All right, it's in the chat. The homework and the solution. Do me a favor, download them right now, open them up, see if they're readable.
Yeah, they're pretty good.
Did anybody's like not work or whatever?
I'm good.
I actually satisfied Ridvik. Oh my God. Wait a minute. I thought I would have to like pull out a slab of marble and carve it.
For some reason, I can't open it. It just shows. It's not like it says disk IO error.
Yeah, mine says that too.
Yeah.
I'll send the picture. Hold on.
All right.
Thanks,
Thank you,
Reed.
Vic.
Yeah, and he won't take 6 months to do it. On 11, is it e squared? Is the you talking about the question or the answer, Ro?
On the question.
All right, give me a second. I have to get there first. You're asking about number 11. Y prime. That sucks. There you go.
Thank you.
Sure, man. Okay, did everyone see? Raul said the picture was kind of blurry, so I'm hopefully. Oh, damn it, it worked a second ago. There it is. Just so that everyone sees number 11, if the picture was a little crappy. Okay. Just make sure that you're reading it since we can actually read it here. What the hell? Screw it. Okay. doesn't seem to work. Does anyone have any problems with any of the problems? Okay, well, if you haven't already turned in your test corrections, please do that right away. I want to be done with my grade book on Monday, which means I want everything in there. So please get it to me so that I can at least not fail everyone. Okay. All right. Now, really quickly, in the private chat, before you leave, tell me what grade you think you should have right now in the private chat. And why?